Hi, everybody. So Paul Goodson's here. Yeah, thanks for joining us. This is, I think it's our first webinar for the for 2022. It's been a strange year so far. Hopefully, things will start opening up. But we thought we'd like to just give a bit of a sense of kind of a higher level view of the the value that Maple MBSE has been giving to our customers, just so you get a sense of this is much more than just using Excel for doing systems engineering work. It really does allow all the various engineering tasks to connect into the systems engineering process as part of your digital transformation of the engineering design process. Just in terms of our experience so far, here we go. Yeah, the challenges that many of you are facing can be kind of loosely described in or generally described in sort of three statements. Typically, you've got the and that's reflected by the various stakeholders that are involved in the project. So you would have this, the programming director or this engineering director, is looking at the implementation of an MBSE within the organization's projects. And maybe we could be concerned about is this actually living up to expectations? Are we getting the results that justify the investment into doing this? We've heard this from several program managers that they see that it's important to have a systems engineering process in place and the tooling and the people for doing that, but it takes a long time to get to start to see a return on that process. Of course, that puts pressure on the systems engineer, and he or she needs to be able to make sure that the process is successful, and that really involves getting the information from subject matter experts and other stakeholders in order to get the level and detail of engineering data from their activities in order to go into the systems model. And very often that can be quite a painful process. It's wide open to misinterpretations and miscommunications, and errors start creeping in, which then of course shakes the confidence in the process among everybody else. And then the other stakeholder in all of this are the subject matter experts, and they're seeing this process as almost like a burden that they're expected to understand concepts of SysML or system model development, and need to learn sort of various concepts and tools in order to give the systems engineer the information in the level of detail consistency that's required for them to do their work. So there's a lot of these challenges that are sort of that can sort of impede the success of the engineering process. And this is where we think we can come in with Maple MBSE. We can really help with this. We can by having the ability to integrate the various stakeholders' activities with the systems model through an easy Excel user interface. This really does enable collaboration across the board, and allows stakeholders to work with the systems engineer directly through the systems model. This then does address that need for having consistent integration of engineering content. This can be done very rapidly with Maple MBSE, and thus this will help to accelerate the introduction of MBSE within the digital enterprise and integrate all the various activities in that way. And of course, that keeps the program manager happy, because that then reduces significantly reduces the risk to the project and any unbudgeted costs that can arise from things like errors creeping into the systems model, which and the ensuing disruption that can cause. So the idea here is that all three parties can see that there's a real benefit to using our tool for this kind of work. So how do we do this? What is this amazing tool that allows us to do all that? Well, the first thing I want to make sure that everybody understands is that this isn't about Excel export or import of Excel files. This is about a very tight integration between the systems model. So any information that is required by the end user can be served up from the systems model, from whether it's a Capella or a SysML model, and then that view can then be created that creates a view into the systems model that's specific to that task. And we'll see in the demonstration that this isn't just a flat file of information. All the various interdependencies for the elements are also reflected in a tabular form. Of course, any changes that are made in this interface can then be integrated back into the systems model for the systems engineer to be able to review and then authorize any changes that go into the final authoritative source of truth. It's a familiar user interface. It's probably by far the most popular engineering design user interface in the world. It's not. The irony is not lost on me that I've spent 30 years of my life telling engineers that they shouldn't be using Excel for doing engineering work. But in fact, in this particular case, it actually does make a lot of sense to be able to manage all the information in tabular form without worrying about the intricacies of creating the systems model. All of that is handled in the MBSE layer. Of course, there are going to be many different applications that will require configurations of this task view for the specific tasks. Every customer is different in terms of the kind of information that they need and the kind of information that's available in the systems model. So the back end needs to be highly customizable in order to create those front ends that make it easy for the end user to use. And currently we have integration with certainly three of the main SE platforms. So Rhapsody, IBM's Rhapsody, Magic Draw, Cameo Systems Model through Teamwork Cloud, and then last year we released an adapter for Capella. So the kinds of applications that we get into and involved in, as I mentioned, these can be a myriad of different Excel-based tasks or tabular-based tasks that we can configure Maple MBSE to support. But these are some of the typical ones that we do get involved in. So things like ICDs, IRDs, safety analysis, FMEA types of applications, trade studies, variant management, various aspects of the product lifecycle management or engineering, and even just as a design review tool. And these are just some of the examples, but in general, where we see the greatest benefits of tasks that require large amounts of information to be integrated with the systems model. Probably our number one application is integrating equipment lists into the systems model. Those lists tend to be flat lists with some kind of implied hierarchical structure in it. And it's actually really very simple for us to actually apply that hierarchy to the systems model. So we actually have, you know, main system, subsystem, subsystem, right down to the component level. Tasks that have already been performed using spreadsheets, safety analysis, FMEA types of applications, mass, energy, cost, budgets. These can all be integrated quite successfully into the systems model. And the one we're actually going to talk about a little bit more today are tasks that require specialist skills and knowledge to generate information. So very often the system engineer really can only get to a point or a level of granularity or a high level, sorry, a low level of granularity, and requires the knowledge from the SMEs to be able to decompose those high level components or elements and break them down into something that's going to be actionable or testable or verifiable in the design process. One task that we do get involved with quite often is functional decomposition, and we're going to talk about that in our demonstration today. And then, you know, as I mentioned earlier, then tasks that require the system engineer to be able to do some kind of analysis of the model itself. So things like impact analysis, design structure matrices, traceability analysis, the kinds of things that just lend themselves much better to a tabular representation. Again, can be carried out very successfully with Maple MBSE. Okay, so that's really just a higher level introduction to what advantages Maple MBSE can bring to your organization. What we're going to do today is Bharani and I are going to sort of play two different roles. So Bharani is going to be the systems engineer. So he's the guy that's familiar with SysML. He's familiar with the structure of the systems model, and of course is charged with bringing in information into the systems model. As you know, is familiar with tools like Rhapsody, or in this particular case will be Cameo systems model. I'm going to play the role of the design engineer that is being charged to focus in on one particular aspect of the system and populate that with sort of the various put in a new high level function and then decompose that down into a series of lower level functions while still maintaining the relationship with the rest of the model. I'm going to pass this over to Bharani, who's going to give you a bit more of an in-depth walkthrough of what the demo would look like, and then we'll go into the actual live demo.
As Paul mentioned, what we will see for today's demo is we'll see a workflow of functional decomposition, and we will use an activity tracker as an example system model. So what we will do is we will identify the functions. So in terms of functional decomposition, what we expect from subject matter expert is you already have the requirements or top level functions, and you expect the subject matter experts to break it down into lower levels and continue up to certain granularity, like to basic functions. So by basic functions, we mean like you will be able to allocate this function to certain component that will carry out the function, or you can relate it to certain requirement that clearly explains what is expected from the component, like in terms of function and so on. And then you will be able to identify the inputs and outputs for the functions. And we also want to allocate the function to different components. And finally, we want to verify if all the requirements have been met. We also want to maintain the traceability between the functions and the requirements from which the functions were defined. So with Maple MBSE, what the user can do is the user can easily identify the functions from the top level function, or in today's case, what we will see is we will see requirements from which we will identify a function, we will decompose the function into subfunction. And the way I want to capture this decomposition is using a composition relation in SysML, and I will be able to see the composition relation today. And then finally, I want to allocate these new function that were identified from a requirement to different components. But in overall, what Maple MBSE is capable of doing is it can translate all these changes or all the different edits that we are going to do with Excel into SysML model elements. Like we will see requirements that is already in the model. We will identify new functions. You will be able to perform the functional decomposition by breaking it down, relating all the functions together, and so on. But for the scope of today's webinar, what we will do is we will keep it to a simple workflow in which the system expert is going to just identify the function and then decompose into sub-functions. And then I also want the subject matter expert to link the functions that were identified to a requirement so that I'm able to maintain the traceability between the function and the requirement that led to this function. And finally, I want the expert to also allocate the functions to components that are going to perform the functions. And this is the workflow that we will see. And once this is done, I'll show the model again in Cameo, and we'll be able to see how all the traceability relations and how the information that was added to Excel is being translated as SysML elements itself. And in the model, I already have the model with certain functions that are defined, like the activities, as you can see here. And we also have requirements that is already defined. So I have a requirement that is being defined as an hierarchy, and we also have certain components here. So this is what we are going to see. We will see the functions. There will be new functions that are being added, and these functions will be related to the requirement and also to the components. So once this is done, I'll show the relations again in Cameo.
Okay, so what the end user will see when she starts the program, they'll see an icon that just has the application. So this is the configuration file that actually sets up the application in Excel. I've already done that because it takes a little while to connect to Teamwork Cloud. So here's the connection dialog. I'm going to select the activity tracker. I hit OK. What I did, and no. All right, so now we're loading the model. So this takes a little while, but what's happening under the hood is it's extracting the information from the SysML model in Teamwork Cloud, and then creating the task view. We have it here. This up. So I'll start with this view. It's really just some documentation just to describe what the different tabs are providing. But these map to the requirements for the functions, decomposition, and the allocation matrix that Bharani just took you through. So these are the tasks that are down here. So the first thing I want to be able to do is, well, first of all, review what's already been done. So this is the information that's come out of the systems model, and you'll notice that it's not just the list; it's also the interrelationships, the dependencies that are being captured in the systems model. And in fact, what I'm going to do is I'm going to just add a new high-level function into here, which is track steps. So that's been entered and now has been captured as a new element in the systems model. And what I want to do is to basically this function will address or satisfy this requirement, the track steps requirement. So I'll check that one off. There we go. So now that I've got that that new element, that new function in here, I can now go into the decomposition page. Now, what we're seeing here is, well, all the functions, the list of every function, and then we have the sort of hierarchical relationships for each of these operations. So so connected for smartphone is a sub-function to display notifications and so forth through here. And then you'll see that we actually have the new function that I've just added to the list. So what I'm going to do is add my knowledge and the decompositions that I want to put in here. So first thing I'm going to do is I'm going to add altitude. So I'll just grab that, and I know it's going to be a sub-function to track steps. And altitude. So that's now been captured, that relationship. I'll add another sub-function in here, find pressure. So I'll do a couple more in here, determine activity. And then determine activity can be broken down into several other functions. I'm just going to add one more level of sub-function in here. So the way I can do that is I can just add it to this, determine activity, and send data to processor. And then that's the full hierarchical structure is then captured here. So it's a sub-function of determine activity, which is a sub-function of track steps. Just add one more in here. Which is the store data. Okay, so that's just me adding those sub-functions into the into this table, and then Maple MBSE is then capturing what the hierarchical structure relationships looks like. I can do one more thing, and that is track steps is actually a sub-function to track daily activity. So I want to be able to make that relationship in here. So what I can do is I'm just grab that and then grab that, and then everything else just falls into place. All the various relationships then can be seen. So all the sub-functions are then visible. Now what I can do, now that I have those new functions, I can start allocating those to the various components in my system. And you'll see here these are all the new functions that I've added to the system. So I'm going to start with track steps, and I'm going to say, okay, well, I need that 3-axis accelerometer. Oh, wrong one. Three-axis accelerometer for the find pressure and altitude. That's the pressure sensor. The determine activity, that is part of the screen. And then I'll just add these ones in. Part of the store data as part of the storage unit. That's it. All right. So I've now got all the various relationships connected between the functions and the hierarchy of those functions, how they are attached to the components, and more important, and and above all, how that's connected to the requirements. Now that I've done this, I can now commit these changes to the systems model. So let me fire this up, and the track steps function. Just something that gives the system engineer some information on what the nature of the changes are that I'm committing, and click OK. And that's it. That's all there is to it. All that information now has been restructured in SysML. It is now ready to be reviewed by the systems engineer. Over to you, Barani.
If you notice, like, we are in revision 17, and since Paul added new information and committed to the server, we would have moved to the latest revision. So as of now, you still do not see any of the changes because we are still in the previous revision. So I'm going to update my project here. So once my update is done, we'll be able to see all the new functions and the relation that Paul just added. And you can also notice that the track steps and like the determine activity or find pressure, all these functions were added to the activities package, which is inside a top level model fitness tracker package. So as you can notice, like I in the configuration file, I would have already determined like which part of the model the new element should be added to, and which part of the model should be exposed to the user, and so on. And nowhere in Paul's workflow, he mentioned that the function has to go into a package called activities, or the relation has to go into a requirements package, or etc. And what kind of relation should be created. So everything is determined in the configuration file. All the subject matter expert will do is to add the right information and save it in the model. So to visualize this, I'll create a new diagram. And we will just drag in the information of all the functions that were added. Track step, attitude, pressure, determine activity. So here, and you can already see the hierarchy here of how the hierarchy is being stored. Track daily activity. So you can see, so all these new functions were recently added by Paul, and we can see the hierarchy being captured exactly. And similarly, he also made links to the component through an allocation. So to 3-axis, the parameter, storage unit. Again, if I drag and drop these, you'll be able to see all that relations being captured exactly. So it's being captured as an allocated relation. And track step also is something that was related to the requirement. So here you are able to see all the relation that Paul created. So here we are able to see like the requirement from which the track steps activity was refined, and then it was decomposed into different functions, which were then allocated to components like the pressure sensor, the storage unit, and so on. So the workflow is again bidirectional. I will be able to make some changes here and send it back to the model. For example, say the function to send data to processor. And I review it. I find that there is a mistake with this one. So it's actually the function that has to send data to a processor application and not the processor itself. I can make this change and save my change to the server. Okay, once I commit my changes, you'll also see we move on to the latest revision, and once Paul updates to the latest change, you'll be able to get the new change.
So now I can go into the add-ins menu here and then just update. Yeah. And now we can see the change being made. Obviously, it's a fairly trivial change, but as you can see, any changes to the structure, anything else will be reflected in the systems model. Okay, I think that's as much as we wanted to present to you today, just to give you a sense of what how Maple MBSE can really make the process of adding detailed information into the systems model a lot easier, and that then really helps in just connecting all the various tasks together. Let me just do a quick wrap up. So as far as implementing Maple MBSE is concerned, yeah, there's a huge amount of value to be derived from Maple MBSE and implementing it, but to really get the full value out of the tool, we do strongly recommend that you acquire our services along with the tool, so that we can make sure that either your experts on your side are brought up to speed and as quickly as possible in terms of configuring and deploying Maple MBSE applications, or we can do those configurations for you. We do a lot of this kind of work. We can turn them around very quickly, and of course test them and make sure that the end user is getting what they're expecting in terms of the tool. Also, the Maple MBSE is very flexible. It's very open. You can do a lot of custom work, and we have done quite a bit of work for various customers to either customize the views or some of the functionality to be much more aligned with the needs of our customers. So typically, when we get into a discussion about implementing Maple MBSE, we will be getting into a discussion about how we can train or guide you through the process. So with that, that's the end of that sort of formal presentation. I think the whole goal of Maple MBSE is to be able to create that connectivity between the various tasks, engineering tasks or other tasks that where that information needs to come from the subject matter experts into the systems model, not only for the systems engineer to use, but of course everybody else to use within the design process. And this really does help to reduce the errors and disruption and unbudgeted costs in the project, and really minimizes that risk and increases the likelihood of project success.